Hi students, so in this video we will discuss about combination of resistances. So what are the resistances? Resistances are some kind of devices, like for example some bulbs are there. So you can connect these bulbs in two different ways. One is that you can connect them like there are two bulbs, so you can connect the bulb 1 and bulb 2 like this, right, with the battery. And there is another way you can connect, is that this is bulb 1 and this is another bulb 2. This is another way of connecting. These are two simple way of connecting a bulb to the battery. So this kind of combination we will call it as series combination. So this is series combination. What is happening in the series combination of resistances? One resistance is connected to the another resistances, and then another resistance is connected to the next resistance, and then that is connected to the battery. Okay, so all the resistances in series combination are connected through one wire, whereas in case of parallel combination, all of these resistances, they are directly connected to the battery. So this we will call it as parallel combination. Okay, so let's understand one by one all of these two combinations. So this first is series combination of resistances. Series combination. So for understanding purpose, I am just taking two resistances. We can extend this resistance to the any n number of resistances. Okay, so here this is the circuit. Let's take the first resistance is R1, the another resistance is R2, is connected to a DC source of voltage V, right? So when we connect to the DC source, immediately current I will start flowing, right? This I will flow this from the resistance 1 as well and from the 2 as well. So this is the characteristics of series combination of resistances, is that current through all the resistances will be same. So current will be same in all resistances if they are connected to the series combination, right? So let's take the potential drop on the first resistance is V1 and on the second resistance it's V2. So can I write down according to the Ohm's law, V equals to IR? So can I write down potential drop on the first resistance V1 as IR1? Right, let's call it as equation 1. And then V2 potential drop on the second resistance as IR2. Let's call it as second equation. Now can you tell me what is the ratio of V1 V2? So V1 divided by V2 is equals to R1 divided by R2. So this is the ratio of potential drops in case of series combination. Series combination, in case of series combination, potential is directly proportional to the resistance. Okay, so if we know the total potential is V, from there we can write down V1. Okay, that will be V R1 divided by R1 plus R2. Similarly, we can write down the other formula of V2. So V2 is the potential drop on the second resistance. So if you want to calculate in any complicated circuit and we know the total potential drop on both of them, so we can apply that VR2 divided by R1 plus R2. This will be very helpful for the complicated circuits. Now let's calculate the equivalent resistance. What is the equivalent resistance? Like for example, instead of these two resistance, I just want to use one resistance which gives the same power output, right? So what will happen when I will connect this equivalent resistance it will give me same current at the same potential, then I will call it as equivalent resistance. Okay, so can I write down from here V equals to IR equivalent. Let's call it as equation 3. Okay, so from equation 1 to 3, and I know that V equals to V1 plus V2, let's call it as equation 4. So equation 1, 2, 3 is value. If I put in the equation 4, I can write down as IR equivalent equals to IR1 plus IR2. I will be cancelled out. From here I will get the formula of R equivalent, that is R equivalent equals to R1 plus R2, so on. So this is equivalent resistance in case of series combinations of resistances. Okay, so this is series combination. Let's go on the parallel combination of resistances. So parallel combination. What is the parallel combination? Where the resistance are connected directly to the battery. Okay, so like for example, here is the resistance 1 and this is the another resistance 2. They are directly connected to the battery. Now see, many times we will not be asked these kind of very simple questions. We will be getting complicated series and parallel combinations. So in that we will use part of calculations of parallel combination and series combination, right? So let's call it as the resistance is R1, this is R2, it is connected to V, right? So now this V potential is plus here minus here, this battery is creating a potential difference. So now this potential difference is transferred on the first resistance as well on the second resistance. That's why in case of parallel combination, both the resistance 1 and resistance 2 will have same potential drop. Okay, so in case of parallel combination, all the resistances will have same potential drop. Will have same potential drop. Right? Able to understand this, right? So let's now write down the I1. What is the current in the first circuit? See, in this first resistance current is I1, second resistance current is I2. Obviously they will be different, and I1 will be V divided by R1, isn't it? And I2 will be V divided by R2. Okay, so if I calculate the ratio of I1 divided by I2, that is R2 divided by R1. So here, from here we understand that current is inversely proportional to the resistance anyway. So that's why I1 divided by I2 equals to R2 divided by R1. If there are multiple resistance, then we can write down I1 ratio, I2 ratio, I3 equals to 1 by R1 ratio, 1 by R2 ratio, 1 by R3. Okay, so if I know the total current, so I can calculate I1. How I can calculate? Using the ratio formula. So I1 will be I R2 divided by R1 plus R2, ratio multiplied divided by total sum of ratio. I2 is I R1 divided by R1 plus R2. Okay, so we have calculated I1 and I2 in the form of ratios. So now let's go on the equivalent. So now instead of these two resistance, if I just want to use one resistance which gives same power output, then I will call it as equivalent. Okay, so for the same power output, the current should be flowing same at same potential, right? So can I write down I as V divided by R equivalent? Let's call it as, okay, this is equation 1, this is equation 2, and this is equation 3. And I also know that I equals to I1 plus I2. Okay, if I just place the values of I1, I2 and I in this equation 4, so then I will get V divided by R equivalent equals to V divided by R1 plus V divided by R2. From here I can write down 1 by R equivalent equals to 1 by R1 plus 1 by R2, so on. So this is equivalent resistance formula. Okay, so we can use this equivalent resistance formula for the parallel combination. So this is parallel and series combination of resistances. I hope you must have understood it. Okay, so thank you very much.